Okay, in previous videos we've talked about what antiderivatives are, or the indefinite integration of a function, and what we figured out what that was. We've looked at various rules, our power rule, our constant multiplier rule, our constant rule, our sum and product rule of indefinite integration. Now we're going to get into some examples and see how all of this works together. Alright, so we're going to start with the indefinite integral of x to the 6th power with respect to x. And what we're going to do is we're going to use our power rule, and we've got 1 over 6 plus 1 times the x to the same power, or 6 plus 1 power, x to the 6 plus 1 power. And then remember, we always have to tack on our constant of integration plus c. So we're just going to simplify this nice and easy. 1 over 7 x to the 7th power plus c. Right? Just using the basic power rule. Pretty straightforward. Okay, let's look at another example. The indefinite integral of 4 with respect to t. Now this is going to be 4t, right? So we're just taking a constant, so this is our constant rule, and we're just multiplying it by our variable. Now, and we're adding our c on at the end. Now keep in mind that this t, it doesn't always have to be an x, right? Normally we do with respect to x. This time we're doing with respect to t. So just make sure you keep your variables in line as you're working through these examples or any other problems. Alright, so the indefinite integral of 3x to the 5th power with respect to x. Alright, so this, we're going to start by 3 times the integral of x to the 5th power with respect to x. This is our constant multiplier rule. Alright, so we take 3 and we multiply it by whatever the indefinite integral of x to the 5th is. So we're going to take 3 times 1 over 5 plus 1, and then x to the power of 5 plus 1, and then of course plus c. So we're going to do a little bit of simplifying here. 3 times 1 over 6, x to the 6th power plus c. We can simplify 3 and 1 6, and we come up with 1/2 x to the 6th plus c. Alright, so that's just kind of doing all of our simplifying and working all the way through there. The integral of 3u to the 4th plus 6u squared plus 2 with respect to u. Alright, so now we've got a longer function here, but it is just using our sum and difference rule, along with our constant multiplier rule and our power rule. So we're going to be using a few different things in here. So we're going to be looking at the indefinite integral of 3 times u to the 4th with respect to u, plus the indefinite integral of 6u squared with respect to u, plus the integral of 2 with respect to u. Alright, so we're going to take each of these pieces. So we get 3 times 4 plus 1, right, using our power rule, times u to the power of 4 plus 1, plus 6 times, now we're using our power rule again, 1 over 2 plus 1, times u to the power of 2 plus 1, plus the indefinite integral of 2u, because it's 2 with respect to u. And then, of course, we always add on our plus c at the end. Alright, so doing a little simplifying. 3 over 5, right? So just simplifying the fraction and the whole number there. We got u to the 5th power plus 6. Alright, 2 plus 1 is 1/3. So 6 times 1/3, that's going to give me 2. So 2u to the 3rd power plus 2u plus c. And there we go. So we have our indefinite integral of this function as well. Alright, we got 2 more to look at. So we're taking the indefinite integral of x plus the cube root of x with respect to x. Now we haven't talked about the cube roots, but it's really, again, just a function with a fractional exponent. So let's rewrite that and make it a little bit easier to see. So we got the integral of x plus x to the 1/3 power with respect to x. Split this into 2, so the indefinite integral of x with respect to x plus the indefinite integral of x to the 1/3 with respect to x. So now we just take it piece by piece. So we have x over 1 plus 1 times x to the power of 1 plus 1 plus 1 over 1/3 plus 1 times x to the power of 1/3 plus 1 plus c. All right, so let's take a look. How does this simplify? We got 1 over 1 plus 1, that's easy enough. 1/2 x to the second power, right? 1 plus 1 in the power, 2. All right, so plus, let's take a look at this piece, and let's do a little bit of working over here to the side, just to kind of get our fractions sorted out. So we got 1/3 plus 3 over 3 equals 4 over 3, right? So we just changed our 1 to a common denominator fraction, 3 over 3. We get our 4 over 3. Now this is 1 over 4 over 3. So that's 1 divided by 4 over 3, which is the same as 1 times the reciprocal of 4 over 3. So we end up getting 3 over 4. Okay, so we have 3 over 4x, and now we've got 1/3 plus 1. Well, we just did that. That's 4 over 3. And then we have our constant of integration plus c. All right, so let's check to make sure all this works. 2 times the 1/2, yes, that's going to give us 1x. 4/3 times the 3/4, that's going to give us 1x and leave us to the 1/3, so we're good. All right, so the indefinite integral of x plus 1 times x minus 3 with respect to x. Now again, I mentioned before that we didn't do the product rule or the chain rule. Those are a little bit more complex. We're going to take care of those in later videos. So what we'll do now is we'll just rewrite this by multiplying these two binomials together. So we get the indefinite integral of x squared minus 2x minus 3, all with respect to x. We're going to split that into 3, right? So the indefinite integral of x squared with respect to x minus the integral of 2x with respect to x minus 3 with respect to x. All right, so we just do our working here. So we get 1 over 2 plus 1 times x to the 2 plus 1 power minus 2 times, well, we have to do the indefinite integral of just x. So the x is to the first power, so we have to go 1 over 1 plus 1, and then x to the 1 plus 1 power minus 3x, right? So we're just using our constant rule, plus c. All right, so a little bit of simplifying here. 1/3 times x cubed, that's good, minus, all right, let's say we've got negative 2 times 1 over 2, so that's going to be minus x, or minus 1x squared, because we got the 1 plus 1 in the exponent, and minus 3x plus c. So that's using our rules of indefinite integration and a number of different examples. Again, sometimes you can just take them straight away and just start solving them. Sometimes you need to do a little bit of rewriting like we did in the last two examples. But I hope seeing this kind of helps get an idea of how to find the indefinite integral of a given function.